We have the altitude. You can see we're a little below 8,000 feet.
Yeah.
On the left-hand side, we have the airspeed. In this case, that's 300 knots, which is about 345 miles an hour.
Astronaut Carol Bo-Bobko is telling me how to land the space shuttle. It's not the kind of thing I need in my normal life, but this is no normal place. NASA's Ames Research Center, in the heart of Silicon Valley, is where astronauts like Bo came to practice shuttle landings before the real thing. He's flown on the shuttle 3 times, once as a pilot and twice as mission commander, logging 386 hours in space. Now he's one of the team that runs the simulation laboratory here and will be accompanying me on my flight inside one of a handful of simulators. This one is configured to simulate shuttle landings and is on the ground, but it can be hoisted onto a large hydraulic platform to allow for an even more realistic simulation. As we start flying, things don't get off to a great start, with Bo piloting.
Really slow. Why are we so slow? We crashed. Oh, dear. Yes.
But don't blame the pilot. A configuration error in the simulation was to blame. And subsequent landings were perfect, setting a high bar for me. Now I'm in control, and the shuttle here is represented on the head-up display by the little circle with 3 lines coming out of it. My target is the small circle near the center of the display, and the computer's telling me that to get there, I need to aim for the guidance diamond. Sure enough, when I line up on the diamond, everything else follows.
You got it right on top, but you can expect that it's going to want you to go up a little bit. Yeah. Because it's going to bring you up to the aim point. Here come the pre-flare cues. Pre-flare.
That pre-flare point marked the move from a 20-degree approach angle, several times the 3-degree angle used by commercial airliners, to a 1.5-degree angle. These are very important because the shuttle doesn't have any engines. It's essentially gliding down to the runway, so everything has to be done just right.
You're a little below the touchdown zone. Okay, that's okay. Now bring it up to the nose. Bring the nose up to the horizon. Okay. You skipped.
I touched down, but not quite in the center of the runway. Hey, at least I'm back on Earth, but I haven't stopped yet.
And steer with push on the right pedal here so that you get it going back towards the center.
I'm not quite sure how this snaking across the runway is going to look on the evening news. I finally get things back on track, and successfully the shuttle is coming to a halt. During that approach, I can't get over feeling how much the head-up display, and perhaps many hours of playing video games, aided me in putting the space shuttle down. Its importance is underlined on my next approach, which is to Halifax, one of several alternate landing sites, and today under heavy cloud. I just have to put my faith in the computer that we're on the right track until the airport appears at 5,500 feet. Without the head-up display and the computer aiding things, I would probably be crashing into the ground about now.
And there's runway in sight. Yep.
The runway at Halifax is shorter, so I need to be quicker on the brakes. And eventually again, the shuttle comes to a halt. A successful landing, but Bo says I had it easy.
No, we didn't give you any blown tires, or bad crosswinds, or navigation errors.
Oh, do that next time.
Next time.
So nothing really difficult. At least that means a teeny bit of my astronaut dream can remain intact. At NASA Ames Research Center in Mountain View, this is Martin Williams, IDG News Service.
That speed looks pretty good.